Hello, everyone. This is our proposal. My name is Julio Camacho,
My name is Rochelle Sandana.
And my name is Luis Juarez.
and the name of our proposal is graphene-based filters. So just a brief outline of what we're going to be going through throughout the presentation. So number one, of course, graphene and its beauties. Basically, it's going to be just a brief background about it, just so you're up to speed of what it is and why it's so wonderful to use. State of the art, some of the things that it can be good for, or in our case, what we're proposing that what we can use it for. Synopsis of problems. With just like everything else, there's always something that is going to be an issue with whatever's going on in the world. Therefore, that's why we're trying to come up with something to address that issue. So, solutions to the problem. So, again, we're going to be giving our solution, our perspective on how we can use graphene as a solution to those problems. Limitations of proposed implementation. So, the limitations, again, it's going to be talking about graphene. Not only is it great to use, but just like everything else, it does have its limitations, and we'll go over that in that slide. And then, of course, our conclusion, summing up everything that we went through so everyone can be up to speed.
Graphene is a two-dimensional, one-atom thick material which is known for its flexibility and strength. And even though it's so small, it is still stronger than steel. Some of the characteristics it's known for are its transparency, its high conductivity, and it's known to be the only substance impermeable to gas. And it's also known for its antibacterial properties, which would be very important to our proposal today. It can also be described as a single layer of graphite, which is only composed of carbon atoms organized in hexagonal arrangement. This can be seen in the figure provided in the slide right there. Graphene sheets are also known to be very versatile. It can be created into buckyballs or into carbon nanotubes. And once it's converted to carbon nanotubes, it could be able to detect and filter toxic particles up to parts per billion.
Our state of the art. So our proposal is to develop a graphene-based face mask that can be used to filter the air and remove the impurities which we breathe. This would also perform as a non-invasive sample testing for COVID-19. This is relevant to what's going on in the world today with the current coronavirus pandemic. With graphene's versatility being able to being able to be converted to carbon nanotubes, it allows carbon nanotubes or specifically graphene carbon nanotubes to be used as a filter, and it would be able to filter out potential COVID-19 particles, which would be used in our proposed face mask. With this graphene-based face mask, the spread of COVID-19 could be reduced significantly and resolve the issue of disposing non-biodegradable masks into the environment. This would as well bring comfort to individuals wanting to get COVID-19 tested.
So as for part one of the synopsis of problems. So with the world currently fighting against COVID-19 or coronavirus, masks have become very important tool. While surgical masks and unfitted KN95 respirators have shown to have a 95 to 90% reduction of aerosolized particles while speaking and coughing, most homemade masks have over 100% increased emission rate. These masks are also not antibacterial, which of course it risks secondary transmission. So let's say, for example, you're using a mask and it gets not necessarily COVID or what have you, but you touch it because you're touching other things and you have to touch your face or whatever. Um, the the risk of you transmitting whatever it is that you touch from your mask to another person or to another mask is a lot higher because that bacteria or virus, those particles do not die. They stay living there on the material. They not only that, but they have a negative impact on the environment by being difficult to decompose. Now, going back to how they have the 75 to 90% reduction rate of aerosolized particles while speaking and coughing, they're good for viruses, for different particles. However, as we're gonna find out later within the slides, using graphene within the mask can actually increase the reduction. So not only will it make it a lot better in blocking out those particles, but we no longer will have that negative effect on the environment. So, continue. Another issue with the pandemic is that some of the testing is very invasive. As you can see in the diagram, they have to physically put a device within your nasal cavity, making the person that's being tested very uncomfortable. So, within our proposal with the graphene, we want to incorporate that into perhaps doing a non-invasive way of getting people tested, because the CDC themselves have confirmed that they have not followed safety guidelines in the past and sent out tainted test kits to random testing centers. So we understand the necessity of graphene being able to be used as a non-invasive way to test these things.
Graphene can actually solve a lot of the problems mentioned before. Because COVID-19 has been measured to be 0.2 microns, when we apply that thin layer of graphene within the face mask, it can block particles up to 0.142 microns and smaller. This can be shown in the diagram to the right, where we can see the hexagonal figure of the graphene and the measurement of it being 0.142 microns. Also, graphene's antibacterial properties will help prevent risk of secondary transmission, and it could also be reused multiple times before we have to dispose it. And it's also able to self-clean itself with heat activation from the sun, which can kill any and all toxic particles that were caught. So that means that we don't have to throw it away, which helps prevent risk of harming the environment, because it's not hard to decompose, and it also is more cost effective. The graphene masks can also work as a filter and as a monitor to detect the particles that are coming in and out of our mouths. And this will act as a non-invasive COVID testing. As said before, most COVID tested methods insert a swab into our nose. And if anybody has gotten tested before, they understand the pain that this causes. So this breathalyzer-like mask can help detect those impurities in our breath. And it could detect the toxicity levels in one's respiratory system, and then using a Bluetooth device implemented into the mask, it will send the results to our phone. So this will prevent pain and discomfort that normal COVID testing methods have shown, and the results will be received almost instantly. This also will allow the results to be more accurate and reduce the chance of them being tampered with by people that contaminate the testing devices.
So one of the disadvantages of using graphene filters for face masks due due to the vulnerability of graphene to oxidative environments. This oxidative flaw hinders the efficiency of using it as a particle detector when analyzing a person's breath. This is due to the humidity caused by an individual blowing into the device, and we all know that if we use our mask for using it for more than 5 minutes at a time, more than 10 minutes at a time, except for maybe if we go to a restaurant and we take it off to eat, or we're at home, we don't usually use it. But if we're out in public, going out for a walk, we want to have our face mask on, and we're going to have it for long periods of time, and you're definitely going to be breathing into the face mask. So therefore, limitation would be that there needs to be some type of medium to keep the graphene's molecular structure intact, so it is not affected by these oxidative flaws. So in conclusion, with the increasing interest and research on graphene, this has led to many possibilities in its potential uses. This includes, as we stated before, using graphene as carbon nanotubes, which then can be used in a variety of forms in the medical, industrial, and automotive fields. Our proposal would make masks more efficient, as it would be able to repel and block air dust particles at a more efficient rate. They would also be able to use as sensors of toxic particles. The limitations would have to be worked on as stated before, as graphene in certain environments is more vulnerable due to the oxidation, due to humidity, which could not only just impact the detecting of air particles, but impacts the effectiveness of the mask. We believe that these masks would directly make an instant impact in the medical field, but it would also make an instant impact on one's life. This is due to the current coronavirus pandemic, but it would also apply to our everyday life and our future as we avoid the future mass spreading of diseases.
Right here you can see our citations and our websites where we attained the information that we use in this PowerPoint. If anyone has any questions, just put them in the thread below and we'll get back to you as soon as possible. Thank you very much for listening to our project.
Thank you all.
You.